Assalamu alaikum. Today we will discuss logic gates, which is the basic of any digital system, or it is the basics of, you can say, digital logic design as well. Now let's discuss. First of all, we will discuss that what is logic gate. Basically, any digital circuit which has one or more input and a single output is known as a logic gate, right? And this logic gate is the building block of any digital system, because any system will be made of these logic gates, right? Electrical signals such as voltage or current exist throughout the system, right? And these systems will be of two recognizable values, right? One value will be either high or either low. The high value will be represented by 1 and the low value or the low logic will be represented by 0. We can classify the logic gates into the following three categories: basic gates, universal gates, special gates. Let's discuss these gates. First of all, we will discuss basic gates. In these basic gates, we will show that Boolean functions can be represented either in sum of product form or in product of sum form. There are three basic gates in these basic gates, right? And, or, and NOT gates. First of all, we will see that what is AND gate. AND gate is basically a digital circuit that has two or more inputs and produces a single output, which is a logical AND. And as we have seen that a logic gate consists of two or more inputs and a single output. So AND gate is a basic logic gate, right? And it is represented by this D-shaped, right? And there are two inputs A and B and a single output Y, and it is represented by A dot B, or it is simply represented by AB, okay? Which means that if we will supply 0 in the input A and 0 in the input B, then the result will be 0, right? And we can say that if there is 0 in either case, if there is 1 0, right, then we will get output Y. And if there is input is both the inputs are high, like it means that both the inputs are 1, then only in this case it will give us the value 1 in the output, right? So there is only a one case in which the AND gate will give you the value 1 in the output. This is the truth table of AND gate, and you will represent your AND gate with the D-shaped, right? Now we will discuss OR gate. OR gate will be represented by, now we will discuss OR gate. This OR gate will be represented by a pointed D-shaped, right? Towards the pointed end will be towards the output. And similarly, like we have discussed that as it is a logic gate, so it has two inputs A and B and a single output which is Y, and it is represented by the plus sign. Means when we will see that it is written A plus B, then it should come in your mind that it is a OR gate, right? Let's discuss the truth table of OR gate, right? If there is 1 in either case, a single one or two ones in the input, then it will give you the 1 in the Y output, right? Only if both the inputs are low, means that both the inputs are 0, then it will give you a 0 in the output, right? So you can say that OR gate will give you more high values if there is either single one in either case, in either. Okay, now we will discuss NOT gate. NOT gate is represented by an arrow shaped with a bubble on the output side of the logic gate, right? And simply what it will do, it will complement or invert the input value, right? So let's discuss the truth table. If we will give A 0, then it will give us the output 1, it will complement the input, right? And if we will give 1, it will complement it and it will give 0 in the output. So simply it's you can say that a NOT gate is simply an inverter, right, which inverts the value of input and give you the inverted value in the output, right? So it's a simple truth table of the NOT gate, which is represented by this value, and you can have the expression of NOT gate as a complement, right? Yeah, you can say that it is the complemented form of the input, right? So now discuss the universal gates. NAND and NOR gates are the universal gates, right? And now let's discuss the NAND gate. NAND gate is the inversion of the logical AND, right? It's a very important point that it is simply an inversion of the logical AND. As we have seen that AND case is represented by D, and here you have seen that it is represented by a D shaped and a bubble or a circle on the output side of the gate, right? Similarly, it's a logic gate, so there are two inputs and a single output, right? And as we have seen that it is the inversion of logical AND, right? So we have only draw a bubble towards the output side of the gate, right? So what we will do, how we will represent it, or what will be its expression? Simply we will write A dot B, which is the expression of AND gate, right? And we will simply complement it, right? And simply we will complement the A dot B or the AND expression, right? So we will get the NAND gate. Now let's discuss the truth table. As we have seen that it is the inversion of logical AND. And if you remember that what was the truth table of AND gate, we have only one in at the output side when we will have the two inputs of 1, or we have the high inputs at both the input side, right? So as we have seen that it is the inversion, so if the inputs are 1, it will be 0, as we have seen that it is the complement or inversion of the AND gate, right? And similarly, as we have seen that in AND gate, in either case, if there was 0, then we will have 0 in the output, right? So as it is complement, so if in either case we have 0 in the input, if we have both zeros, or we have 1 0 in the input, right? So we will have the value 1 in the output, right? What is NOR gate? NOR gate is basically the inversion of the logical OR gate. As we have seen that OR gate is represented by the pointed D type shape, right? And it is represented by the bubble or a circle on the output side, right? As we have seen that it is the inversion of logical OR, so simply we will complement the expression of logical OR, right? And let's discuss the truth table. It is the inversion of the OR. As we have seen that there will be 3 high values if there will be either 1 in either case. So as it's inversion, so if there is 1 in either case, if there is 1 in one input or 1 in both inputs, then we have 0 in the output, right? And we will have only 1 in the output if there are zeros in the both inputs, right? Now we will discuss what is special gates. XOR or XNOR are the special gates. As we have seen that special gates, as the name shows, that there will be any special condition for these gates. Okay, so we will see that what are these special conditions. So first of all, we will discuss XOR gate. Its full form is exclusive OR gate, right? And its function is same as that of OR gate, right? Except for some cases when the inputs having even number of ones, right? When we have inputs having even number of ones, right? It is the case when there is input is having even number of ones, we will have 0 in the output, right? And if we have there is also one is in this case, as we have 0 ones in the inputs, or we can say that it is an even number of the ones, right? So we will have 0. And as we have seen that it is the same case as if either it will be 1 in any input, we will get y in the output, right? So these two lines are the same as we have seen in the OR gate. That what was that case? That if there is either 1 in any input, either B or either A, we will get 1. But as we have seen that in OR gate, if there are two ones in the input, then we will get 1 in the output as well. But in exclusive OR, as we have seen that it is for the even number of ones, right? So we can say that it will give 0 if there will be even number of ones. So we will see that exclusive OR gate operation is similar to that of OR gate, except for few combinations of inputs. That's why the exclusive OR gate symbol is represented like that. The output of exclusive OR gate is 1 when odd number of ones present at the inputs. Hence, the output of exclusive OR gate is also called as an OR function, right? It is also called as an OR function because it will give you 1 if there will be 1 in the, if you can say that there will be odd ones in the inputs, right? And how you can represent it? You can represent it by using the same shape of the OR gate, but with the line on the input side of the gate, right? So we can say that it is the special case of OR gate, and as it is the special case of the OR gate, so how we will represent it, or how its expression will be plus with the circle sign. So the plus with the circle sign, as you can see, the plus with the circle sign, it should immediately come in your mind that it is the exclusive OR gate, right? Now we will discuss what is exclusive NOR gate. Exclusive NOR gate, its function is same as that of the NOR gate, except for some cases when the inputs having even number of ones, right? When the inputs having even number of ones. Let's discuss the truth table of the two input exclusive NOR gate. If there is the even number of zeros or even number of ones here, so we will have 1 in the output, and if there are 2 ones in the input, then we will have 1 in the output, right? So we can say that it is the even function, because if there is 1 will be evens, so it will give you 1 in the output, right? How we will represent it? We will represent it with the OR gate, with the, you have learned that you will represent the NOR gate with the circle at the output side, right? So it's the same representation of NOR gate with the line on the input side, right? Which represents the exclusive side of the NOR gate, right? So the point is that the output of exclusive OR gate is 1 when both inputs are of same, and it is 0 when both inputs are different, right? So it will work in either case when the output of the exclusive OR gate is also called as even function, because it will work when even number of ones present at the inputs, right? Now let's discuss basic arithmetic circuits, which includes binary adder. What is a binary adder? The circuit which performs the addition of two binary number is known as binary adder. First, let us implement an adder, which performs the addition of 2 bits, right? An adder which performs the addition of 2 bits is known as half adder. So half adder is a combinational circuit which performs the addition of 2 binary numbers A and B, they are of single bits. It produces two output, sum S and carry C. First, we will discuss the truth table, right? So A and B, and there are the possible values of zeros and ones. 0, 0 first, then we have 0, 1, then 1, 0 and 1, 1. We have C carry in the output and S in the output as well. S is the least significant bit and C is the most significant bit. So now add 0 plus 0, as we have seen in the binary addition, the 0 plus 0 is 0, so there is no carry. 0 plus 1 is 1, so there is no carry. 1 plus 0 is equal to 1 and there is no carry, and 1 plus 1 is equal to 2, which will be represented by 1 0, or we can say that 1 plus 1 is equal to 1 plus 1 carry and 0 will be the sum, right? Now we will draw the expression for S. So let's see that what is S. As we will see that 0, if there are inputs are 0 0, it will give 0. If there is 1 1, the inputs will be 0 as well, right? So, and if there is either 1 in either case, it will give us 1. So it is the expression of exclusive OR gate, right? As we have seen here, that exclusive OR gate has the expression A plus B, and we will have inputs that, as we have inputs 0 1 1 0, so we have the same expression here as we have seen here, right? It is working in, as we have seen that it is working in even function, as we have seen that it will work in, it will if there is 0 0 in the input or 1 1 in the input, so it will give us 1. So it will work in the even situation. Same as the situation with this S, right? As you have seen. So we will say that we have the expression A exclusive OR B, right? First of all, we will draw this, right? So as you can say, A, B is the input. Exclusive OR gate, we have learned that it is the shape of exclusive OR and S will be the output. Now let's discuss the C. Now I will highlight the C and we will see if there is 0 0, then we will get 0. If there is 0 1 in the input, we will get 0. 1 0 in the input, we will get 0. If 1 1, then only in this case we will get 1. As we have learned that this is the case of AND gate, right? As we have learned that A dot B or AB will the expression of AND gate. So we will say that C equals AB. Now let's draw this C equals AB. As you have seen, we have lines from this input and AND gate is used and the output is C. So it will be the circuit diagram of half adder. And as you have seen that there are two logical gates are used in the half adder. One is exclusive OR gate and the other is AND gate. Now let's discuss full adder. When there is a situation that you have to add the carry bit with the input A or B, then you have to use the full adder. So there will be A and B in the input and a carry in the input. And what will be the outputs? S, as you know, S is the sum, and C out is the carry. Okay, these two are the outputs and there are three inputs in this case, right? So let's discuss the possible outcomes, which are 0 0 and 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1, right? So first of all, what we will do? We will add A plus B, then the resultant will be added by Cn. So let's do this. A 0 plus 0, A plus B means 0 plus 0 equals 0, 0 plus 0 is equal to 0. So the sum will be 0 and the carry will also be the 0. Now let's discuss 0 plus 0 equals 0. 0 plus 1 is equal to 1, and there will be no carry in this case. Similarly, the case is same as 1 plus 0 and 0 plus 1. And as we have seen, 0 plus 1 is 1. 1 plus 1 is 1, 0, as we have seen in the full adder as well and the binary addition as well, that 1 plus 1 is 1, 0. 0 will be the sum and 1 will be the carry. It is the same case as we have seen here, that 1 plus 1 is 0 will be the sum and 1 will be the carry, right? So you can say that it's same if there are two inputs in the one will be, there are two ones in the input side, right? So it is the same case, 1 plus 0 plus 0, so the sum will be 1 and there will be no carry. And if there are two ones, then we have 1 0. Similarly, there are two ones, we have 1 0, and now we have three ones in this situation. Then what will we do? 1 plus 1 is 1 0 as we know, and 1 0 plus 1 is 1 1, or you can say that 1 plus 1 is equal to 3 in decimal, and 3 is represented by 1 1 in the binary form, as we have learnt in the earlier chapters as well, right? Now let's draw the expression for S, right? As you have seen that it is 0 when the three inputs are 0, right? If there is 1 in either case, it will be 1, right? If there is 1 in either case, it will be 1, right? If there is 1 double ones, so it is working for odd functions only, and we have seen that it will be working for odd functions only when there will be the situation is exclusive OR case, as we have seen that exclusive OR case, when there will be, as we have seen, then it will be working only when there is only odd function, right? So it's working for odd function, so it's for exclusive OR gate. So we can write expression S equals A plus B plus Cn. Now we will see the expression for C out, right? So let's see C out. 0 0 0, right? So first of all, we will draw the AB. What is the AB? AB is, if there are 0 0, then you have 0. If there is 1 in either case, you have 0. If there is 1 in either case, you have 1, right? So what you will do? You will do the exclusive OR of A plus B, and it will be AND with the Cn, right? And AB is also, AND gate is used in AB, and overall then an OR gate is used. Now let's see the diagram for this. First of all, we will check S equals A plus B exclusive OR, right? A and B are exclusive OR, and then the input is exclusive OR with the Cn, right? So what we will say, A and B, it is exclusive OR this with this, and then the output is exclusive OR with the Cn again. So we get S, right? And similarly, what we will do, AB, right? First of all, we will check AB, and it is AND gate, A and B AND gate, right, is used, and the output is, then what we have done, output is exclusive OR A plus B is again used, right? A and B exclusive OR, right? This exclusive OR is used with the Cin, and it is AND gate is used, right? And the output is then, what is this? S1 and Cn is the AND gate. This is A plus B exclusive OR with the B, right? And the output is AND with the Cn, right? So this is the situation when AB exclusive OR and Cn is the input here, and AND gate is used, right? So this output and this output is overall then used with the OR gate, right? As we have seen here, it is used with the OR gate here. So we will get the values for the full adder, right? So it is, we have taken this from tutorials point, and you can see other lectures as well from tutorial